Hello everyone, today we're going to talk about linear inequalities. The main thing that we do with linear inequalities is we graph them. Okay, so that's where we're going to start today. A linear inequality is very similar to a linear equation. So a linear equation, it looks like y equals mx plus b, usually when you graph it. These are not going to have an equal sign though, they're going to have inequality signs. That's the major difference. Okay, so there's three major steps in order to graph something. Here's the first step. Just like on a linear equation, you have to put it into slope-intercept form. Okay, the only thing that's different is we have inequality signs. Okay, and I'm going to work out an example over here to the right. So here's our example. Negative 3x minus 4y is greater than negative 12. So in order to put this into slope-intercept form, we're going to solve it for y. Hopefully by now you guys are good at that. So our first step would be to move this 3x over to this side. So I'm going to add it over, so it's positive. Then to get y by itself, I need to move the negative 4 over. This is negative 4 times y, so in order to get rid of that, I need to divide everything by negative 4. Okay, so you get y. Hopefully you're yelling at me right now to flip this sign because we divided by a negative, so it's less than negative 3/4 x. Negative 12 divided by negative 4, that's a positive 3. Okay, that's the first step in graphing a linear inequality. The second step is to graph the line. Okay, the way that you graph the line is the exact same as when it was a linear equation. This is your y-intercept, and this is your slope. The only thing you have to be careful about when you graph is if the line is solid or dashed. So if you have either a less than or equal to or a greater than or equal to, it's going to be a solid line. And what that represents is the line is actually a solution. The points on the line are the solutions. If it is dotted or dashed, your inequality signs are less than or greater than. And what that means is everything up to the line are solutions, but it doesn't actually include the points on the line. Those are not solutions. Okay, so our example here, let me sketch the graph really quick. Hopefully you're using graph paper, so it actually looks better than mine. I want to start off at 3, put a point. Then my slope tells me to go down 3, right 4. So down 3, right 4. So right here, down 3, right 4. About right there. Then I'm going to connect those lines. So it should look something like that, okay? You're probably screaming at me right now and saying, hey, doesn't that mean dashed? Yes, it does. So that should not be a solid line, it should be dashed. So it should look like that, okay? The last thing is, for an inequality, you have to actually shade either the bottom half of the graph or the top half of the graph. Okay? There's two different ways you can determine your shading. The first way you can do it is to plug in a test point. The easiest test point to use would be 0, 0. The test point that you use, though, it cannot be on the line. So if your line goes through the origin, then you can't use 0, 0. Ours, though, it doesn't, so I can actually use that. So if I substitute in 0, 0, these are going to cancel. It's 0 and 0. I get 0 is greater than negative 12. That is true, so I shade on that side. So here this is true, that means this entire side is also true. So I shade that side. Okay? That is one way. If it was false, then you shade the other side. Okay? The other way that you can do it, so I can substitute in a test point, or I can just look at my inequality. Okay? When you get it into slope-intercept form, you can actually tell based on this right here, your inequality sign. You don't look at the very beginning, it's when it's in slope-intercept form. If it is less than or equal to, you're going to shade below. If it is greater than, then you're going to have to shade above. And one thing that you have to kind of be careful about is the y is on the left. If the y is on the right, then it's the total opposite. If I said y is greater than all of this stuff, then I would shade above. If it says y is, like here's an example. Say it looked like this. That says y is bigger than this, so that would actually be shading above. If it was this way, that says y is less than all of this stuff, so that would be shading below. If you always put the y on the left, though, then you will have no problems. It's either above or below based on if this is greater than or less than. Okay? The last thing that we're going to talk about today is whether to determine if something is a solution or not. So the whole purpose of this graph is to show us which ones are the solutions and which ones aren't. So like the point -2, 0, that is a solution because it's in the shaded region. 3, 5, that one is not a solution because it is not shaded. How about, I don't know, 0, 3, that one is on the line, so you'd think, oh, it's a solution. This was a dashed line though, so this one actually is not a solution to our inequality. Another way that you can tell if something is a solution or not, was very similar to using the test point right here. Like if I want to see if the point -2, 5, if I want to see if that's a solution to this inequality, the one that we just graphed, the -3x minus 4y is greater than -12. I could graph this like we just did, or I can just substitute in these values and see if it's true or not. So if I substitute in -2 for x and a 5 in for y, let's see if it's true. I would get a 6. This gives me -20. And then I get -14 is greater than -12. This is not true. This is false. Because -14 is actually smaller than -12. So that tells me that this is not a solution. If you look back on your paper, hopefully you can see that at -2, 5, that area is not shaded. Okay? That's all that I have for you today. Here's one I want you to try tonight, bring it in tomorrow, and then we will check it. So I want you to graph this inequality. I'm going to make it up off the top of my head. So -6x plus 3y is greater than 15. Graph that inequality. Then I want you to tell me, is the point 18, 23 a solution to this inequality? Okay, so graph this, and we'll go over that. Tell me, is this a solution or is it not a solution? We'll go over that when you guys come in. Okay? See you guys tomorrow.